Okay, so in this tutorial we're going to be going over how to write formulas and name compounds. And I've just given you a random list here so that we can practice everything at once. And our first one here we have calcium sulfide. So when you're writing formulas, the first thing you have to do is write the symbols of your formulas, and you have to decide if you have two nonmetals together or a metal and a nonmetal together. So I've included the periodic table down here, and I've also included our list of polyatomic ions so that we can figure this out. So remember, the stair step here tells you whether you've got metals, all of these guys over here to the left, or nonmetals to the right. When we have metals and nonmetals come together, like calcium and sulfide, which means it came from sulfur, then we have to write our symbols, calcium and sulfur. So the symbol for calcium is Ca, and the symbol for sulfur is S. And then the next thing you have to do is you have to decide your charges. And you need to remember that the group number, the little number up here at the top, is sort of your cheater way to remember your groups for your main group elements. So everybody in group 1 has a +1 charge. They're metals, they like to lose electrons. Everybody in group 2 has a 2+ charge. And then we skip over all these guys in the middle of transition metals because they can have variable charges. And we go over here to group 13. The metals will like to lose 3. Boron is a little strange, and so it gains, and it's odd. This is 14, so it's carbon likes to gain 4, and silicon as well. Germanium, tin, and lead are a little odd, so we'll talk about those later. And then group 15, the nonmetals like to gain 3. Group 16, they like to gain 2. Group 17, they like to gain 1. And the reason why these guys are gaining 4, or 3, 2, and 1 is because they want to get to that magic number of 8 for their valence shell. So all of these guys gain the number of electrons they need to get to 8. So all you do is take the second number on the group number, the 4, the 5, the 6, the 7, and you just add whatever you need to it for your electrons, and that tells you the charge, the negative charge. So going back to our first example here, we have calcium sulfide, and our charge for calcium, since it's in group 2, is 2+. And our charge for sulfur, since it's in group 16, is -2. And so when we do metals and nonmetals together like this, we have a crisscross method, or switch the charge method. And so you end up with Ca2S2. And then the last thing you do is you reduce if you can. So since these are both 2, we can say that they would both be a 1-to-1 ratio. So our formula for calcium sulfide is Cas. Alright, looking at number 2, we have phosphorus. Phosphorus is a nonmetal, and we have chloride, which tells us it's chlorine, which is also a nonmetal. When two nonmetals come together, the naming on it tells us how many we have. So the first element, if it doesn't have any prefix in front of it, tells us that there's only 1. And then this prefix here, this penta on the chloride, tells us how many they have. Penta, that prefix, tells us that there are 5. So nonmetals are much easier to write the formula for than metals and nonmetals, the ionic compounds, in my opinion. So we know that this is phosphorus, and we know we have only 1 of them, and we know that this penta means that there's 5 chlorines. So the way that we write the formula for this is P for phosphorus, Cl, and then a subscript of 5. Okay, next one, lithium nitride. Okay, so we got to find lithium. Lithium is over here, so we know we have a metal. And then nitride tells us that the starting is which is nitrogen. Nitrogen's over here. So we have a metal and a nonmetal coming together, which means this is an ionic compound, which means we have to do the switch the charges. So lithium if we look, lithium is here in group 1, which means it has a +1 charge. Nitrogen is in group 15, which means it's going to have a -3 charge. So we have lithium with a +1, and we have nitrogen with a 3 negative. And we do our crisscross method of our charges, and we get Li3 N1, and then we don't actually write that one, so the final way to write the formula for lithium nitride is Li3N. I'm going to put boxes around these final answers so you know which ones are the correct formulas. Okay, phosphoric acid. Anytime you see acid on a name, that tells you it's starting with hydrogen. And since our name of our acid doesn't begin with hydro, this tells us that this phosphoric is a polyatomic. Also, this ic ending here tells us that this came from phosphate. So 8 goes to ic. So all we have to do is come down here to our polyatomic list and find phosphate. Okay, and here's phosphate right here. So we know that this had PO4 3-. Okay, and then hydrogen's over here in group 1. Now hydrogen is a nonmetal, so it acts a little strange. It can gain or lose 1 electron. When it comes with these polyatomic anions that are negative, it likes to lose electron. So we know that hydrogen, you can treat it almost like an ionic compound. Hydrogen has a +1 charge. Phosphate is PO4 3-. So even though this isn't an ionic compound, you can do the crisscross method with this, which means that we need 3 hydrogens to balance out the -3 charge on the phosphate to make phosphoric acid. Okay, next one. We've got mercury, and then we've got this Roman numeral in here of 1, mercury 1 bromide. All right, the reason why there's this Roman numeral here is because mercury, which is Hg, is right here, and it's found within the transition metals. So transition metals are all of these guys that are in groups 3 through 12. So anybody that's in these transition metal group, with the exception of 3 elements, and that is silver, cadmium, and zinc, all have variable charges, meaning because they're in this D block where they can, they have electrons in this D block here, they can kind of gain, or not gain, but lose various amounts of electrons, Zinc, cadmium, and silver are exceptions to that rule. And if you want to remember what charges they have, silver, if you want to think it's in group 11, so it's always a +1 charge. Cadmium and zinc are in group 12, so it's always a +2 charge. You can do that. But remember, it only works for those 3. Copper, gold, ruthenium all have variable charges, and mercury has a variable charge as well. Okay, so we do have mercury 1 bromide here. The Roman numeral tells us what the charge is on our transition metal. So that means that this mercury is a +1 charge mercury. And bromine, if we look over here, bromine is right here. Bromine is in group 17, which means it has a -1 charge. So when we switch our charges or crisscross our charges, we get Hg1Br1, and then remember we don't really write those ones, so our final formula is HgBr. Okay, next one, oxygen difluoride. Okay, oxygen is over here, fluoride is fluorine. They're right next to each other. These are both nonmetals. We also know that these are nonmetals because if we look, we've got this prefix di here. That's a giveaway that this is a covalently bonded compound of 2 nonmetals together. And remember, those prefixes tell us how many we have. So since we don't have a prefix in front of oxygen, that means that we just have one. And the prefix di means 2, so that means we have 2 fluorines. So the way that we write this formula is we write this as OF2. We don't write the 1. Okay, next we have sodium phosphate. All right, so sodium is over here, it's a metal, and then phosphate, which I apologize, that's a typo, it should be phosphate, P-H-O-S-P-H-A-T. If we look as a polyatomic anion here, so this means that we do have a metal and then a polyatomic nonmetal coming together, so we're going to have to do charges. Sodium is in group 1, so it has a +1 charge, and then phosphate, when we look on our polyatomic list, is PO4 3 negative. So we crisscross our charges, and we get Na3 PO4, and we don't have to write the 1 because we only have one of them. So that is the correct way for writing sodium phosphate. All right, hydroiodic acid. All right, this is a slightly different type of acid because now we have hydro in the front. So when we have this prefix hydro, this tells us that we just have hydrogen with the element. It's not a polyatomic. So iodic means it came from iodine. So we have hydrogen and iodine coming together. And we can still do the charges on this. So remember, in acids, the hydrogen has a +1 charge. And then iodine is in group 17. So iodine is going to have a -1 charge. And remember, it's -1 because group 17 is 7. It needs one more electron to be happy. So we crisscross these guys, and we get HI for our formula. Okay, iron 2 hydroxide. Iron 2, remember, iron, if we find it here on the periodic table, is right here in the middle of the transition metals, Fe, and that's why it has this Roman numeral 2 after it. Remember, the Roman numerals tell us the charge. So iron is Fe2+, and then we have to look for hydroxide. Hydroxide is a polyatomic, so we look down our polyatomic list to find hydroxide, and here it is right here in the middle, OH-, which means we're going to have to do our crisscross with our charges. This is -1. So we have 1 iron, and then we have 2 hydroxides. Now the important thing with polyatomics, when you have more than one of them, you have to use parentheses. And you have to use the parentheses so that you say that you have 2 of the hydroxide. If you don't use the parentheses and you just put a 2 over here, then that would mean that you have 2 hydrogens, and it would be an iron, 1 oxygen, and a hydrogen. And that's not correct for the formula. The formula for hydroxide is OH. And so if you're putting 2 of them in there with the iron, that means you need 2 oxygens and 2 hydrogens. And this is the way that you show that, is by parentheses. So just like in math, when you use parentheses and the number outside the parentheses gets distributed to the inside, it's the same in chemistry. So that means everything in here is multiplied by 2. And then our last example here, hydrosulfuric acid. Okay, so hydro, remember, means that we have hydrogen with just the element. It's not a polyatomic. So our element here is sulfur, because this is sulfuric acid. So that means that we have a hydrogen with sulfur. Now we got to figure out what charge sulfur has. Sulfur is over here in group 16, which means it's going to have a -2 charge because 6 + 2 gives us to 8. Hydrogens, remember, when they're with the acids, they're always +1. Sulfur is -2. So when we switch these, we get H2S1. And then remember, we don't write the 1. So this becomes H2S for the final formula. And that is some practice with
writing formulas from names.